All right. Conveniently, I'm going to be talking about the future. So nobody really knows whether what I'm saying is correct. And if it's incorrect, come back and talk to me in 50 years. And if I'm wrong, I'll buy you a beer. So let's just start with that. I run a lab called the Future Reality Lab at NYU. Our mission is basically to understand what various kinds of extended reality will be like when it's just reality. When things that we now consider impossible just start showing up in our world and we take it for granted, just as we currently take for granted things like the internet and smartphones and Zoom. So the timeline for me starts pretty much, I got into VR probably when I was 6 years old, and I would play with little plastic dinosaurs. And at the time, they seemed completely real to me. I would pick up my Brontosaurus and my T-Rex and take them on stories and adventures and romances. And then as I got older, I unlearned how to have that superpower. I somehow needed to read books and see movies in order to get the same sense of being in another world. A formative book for me was Harold and the Purple Crayon, which is about a boy who picks up a crayon and can draw whatever he wants in the world. And it still makes sense to me that that's the way we're supposed to create. When I was 16, I saw Disney's Fantasia and I said, that's what I want to do with my life. And so I went into computer graphics because that was the way to do it when I was leaving college, to do the equivalent of what Disney was doing. And then in 2006, about 14 years ago, I read this science fiction book by Vernor Vinge called Rainbow's End, which takes place in the canonical 40 years in the future, so nobody can say he's wrong. And the premise is very simple. In this future, people wake up in the morning, they pop in their contact lenses, and they can see whatever they want. And the real and the virtual are so seamlessly mixed that it is completely a post-screen world. Stuff just floats in the air between us. And I found this to be so logical that about 5 years later, when the Microsoft Kinect came out, I started doing talks. I did a talk at SIGGRAPH Asia in 2011, where the video screen behind me showed the future I wanted. And I was using a Kinect to draw in the air. And as far as anybody was concerned, I was creating things in the air. And this was really just a concept to show people what the future might be like. But then I said to myself, why shouldn't we be doing this for real? So 2014, I went out and with Luc Dubois at NYU, bought a motion capture stage. And the reason we bought a motion capture stage was that the Gear VR had just come out. And so I thought, wow, just little Samsung phones and a cheapo device. I can put OptiTrack markers on it. We can have all of our students walk around. And for the first time, we can have untethered multi-person shared extended reality. And each of these people is seeing each other in their correct position in the world as an avatar. And then we started doing a sequence of experiments. And since then, we've continued to do these experiments, and let's use whatever technology we can get our hands on to emulate future technologies. Because frankly, this thing plus this thing, if you go forward from 2014, when we started this, to today, now you can do these things for consumer costs, but I'll get to that a little later. So we did a whole series of things. We did something called Holodeck in Wonderland, which was a live theater piece where everybody, the audience and the actors, everybody was in shared VR in the same room as magical creatures. We'd have magical size changes so we could go down to the size of mushrooms and back up again. We did experiences where everybody's a bird. We did Mexican Day of the Dead celebration, all sorts of things. The first thing that we showed publicly was at SIGGRAPH 2015 in LA, where multiple people would just go into the same room and start drawing in the air and see each other as avatars in their correct locations. Kind of like what you now think of as tilt brush or quill, but for multiple people from the ground up, because our philosophy was always, it's about how people interact with each other. It's not for us about the individual experience, but about the sharing and what you learn in that sharing. And then we did this celebration for the Mexican Day of the Dead, and everybody sees everybody as a, so it's basically a riff on Días de Dios de los Muertos, but we called it Dios de los Hollows. And you're in a parade, and it's very festive. And those of you who have Mexican heritage know that's a very, very festive, happy experience of the spirits connecting with people. And then the following year, we worked with the artist Andy Daffy and did something where everybody's a robot. We worked with the artist David Lobser, and he created something where everybody's a bird and a flock of birds. And the basic idea of these things is you see everybody as a magical creature in an alternate world, and yet you're with other people and you're sharing this experience. Or if you're at the robot dance party, in fact, we had people hold up tango phones so anybody not in the experience could look in and see the kind of fun that these people were having. People really enjoy these experiences, partly because it got them out of the sort of the being stuck in a particular age, a particular gender, a particular perception of other people have of them. And people found this very freeing and enjoyable. Then we decided, how are we going to make something that could scale up to hundreds of millions of people? So then we took a step backward, and instead of having these lean forward experiences, we started creating more lean back experiences. So at SIGGRAPH 2018, we handed out Google 6DoF untethered headsets to 30 people at a time. We created a theatrical experience for them, which was basically, we wrote the origin story of virtual reality, which is cave paintings. And we immerse them in a world where each person, no matter where they are, is in a different location in the theater. And so they're seeing and also having spatial audio that corresponds to where they are. And the basic idea is, if you're in a particular place in the theater, you're seeing and hearing the actor, and you're also seeing as avatars the people around you in the audience. So 30 people at a time over the course of several days. We had 2,000 people go through, so we could just really understand what it was like to do this for a mass audience. Then we showed the same thing at the Tribeca Film Festival a year ago, and got another several thousand people. It was very interesting because when you do it at SIGGRAPH, it is a great demo, but you do exactly the same thing at Tribeca, and then it's art. I have no idea why. So then we decided to scale up and say, hey, let's do something 20 minutes long for a cast of 5 and a much bigger audience. And we did the origin story of science fiction, which was Mary Shelley's 1816 creation of Frankenstein. We immersed people in a world where that is all taking place, that creation story. But this time we did it so it could be in shared VR, but could also using the Magic Leap, in a collaboration with Magic Leap. So we could use the Oculus Quest. We have a relationship with Facebook. And we could also, we have a relation with Magic Leap where we would show that it alternately in miniature on a table. And this gave our scientists and our students some really interesting questions to ask, like how do you relate the same story with the same characters if it's in immersive VR versus AR. And this was, this is actually being shown, selected in the current virtual, of course, Cannes Film Festival. So we're starting to tell filmmakers and storytellers, yes, you can immerse people in these theatrical experiences. It doesn't have to be a flat screen anymore for telling stories. But ultimately, our research goal as a lab is to say, hey, in the space between these two people, you know, somebody's putting on a pair of glasses. These are just Bose frames, so they're audio augmented reality. But in a few years, as some of the other speakers have said, you're going to be able to put on something like this, and you're going to be able to see things floating in the air between you. And that is going to create a superpower. Because once children grow up in a world where they can have stuff floating between them, they're going to accept as part of normal reality the things that we only think of as coming from Star Wars. Like, of course, something can be in the air between us floating. That is just a normal part of reality, like we now accept our smartphones. And those children will then start evolving new kinds of language. And it is that evolution going forward of visual language that I think is the real payoff, because anytime language evolves, that is upping our game as a species, because language is, after all, our one superpower as a species. So I started experimenting with creating visual languages. I use it in all my teaching. I have this teaching tool called Chalk Talk, which I'm using right now, where basically if you draw something, the computer can understand it and it can come to life. So if I wanted to teach about you know, pendulums. I can connect this to this, and you can actually see the relationship between the input and the output, or hundreds and hundreds of glyphs that if I draw them, they have meaning because the computer understands that I'm drawing them, and then that invokes a whole bunch of software. And there are just many, many things that I can express. I can express relationships between things in various ways, various kinds of ideas. If an idea comes to you, you can just express that, etc. And so the idea of taking ChalkTalk and putting it out into the shared world between us, two of our PhD students, Jenny here and Carl Rosenberg, have been working on porting this in a collaboration with Facebook Oculus Education Group into a space in between people where you have an immersive teaching tool. If I want to teach you about matrices, we can actually demonstrate matrices at work just by drawing things in the air, and then everything becomes a live simulation. Meanwhile, we're also under a project we're doing with Verizon, trying to understand how can we do this in contrast in see-through AR. So the idea in see-through AR is they're actually seeing this cell model floating in the air between them. The question here becomes, as other speakers have said before, do you want to immerse people completely into another world and then the focus is on the power of that world, or do you want to keep them in this world and interpose objects which then have magical properties as part of this everyday reality, or is there something in between? So of course, as part of all of this, we do research in procedural characters. So we have a whole layer of directable characters. We tell them to sit down, to stand up, to be able to walk places, to pick things up and do things in different moods. They can dance. We took one of these basic characters and grabbed a character on Turbo Squid, and just because people should just be able to rig these things themselves, and because they're procedural, you can change their scale, make them taller, shorter, do all sorts of things with them. And we also have software so people can quickly make their own characters. This character is just basically made by melting together, fusing a number of simple blobs. And it's the same with this character. She's actually, people just put some simple ellipsoids together and then we automatically infer the skeleton and the skinning and eventually the texturing. And also very important is you need to have from low level to high level facial animation. So when you have a script or we have a character with a mood and you say, okay, that means they're talking or they're angry or they're a little bit puzzled, that should automatically filter down from that recognition down to the lowest level muscles. And here we're sort of opening up the control systems so you can see what's going on procedural animation down to the lowest level. And ultimately the idea, and I'm just drawing this now in ChalkTalk, the idea is I should be able to be wearing those future glasses and I should just be able to be thinking of a character that I want to bring to life and draw that character. And because I drew that character should just become part of my world, understand what a table is, bring its own AI with it. If it's hungry and it wants to eat my houseplants, well, it's an autonomous creature, so it has a right to do that. We tested all this out because we got a donation of 30 Oculus Quests, very generous donation from Facebook Oculus Education Group. And so I just handed out to every one of my grad students an Oculus Quest. And I told them, hey, go ahead and play with the Oculus Quest, do what you want with it, it's yours, have fun with it. And then they did these projects at the end of the semester, which were all group projects. They were all for multiple people who were physically co-located and said, let's make a game, let's make a simulation, let's make a journey, let's make a story, whatever they wanted to do. But it had to be for at least 3 people in real time collaborating over a wireless network, walking around. Because the great thing about the Oculus Quest is it's a consumer device. And this is just something, I have several of these things here in my room because they're inexpensive and they actually give you true sick stuff. I think this is actually the first really practical consumer VR headset. And then we had a choice of what platform to use. There are all these features in Unity and Unreal. And of course, we built our own persistent object server for them to build things on top of. But eventually we decided that we were going to go with the WebVR, WebXR dimension, partly because it's open source, partly because you can just go to URL and run it, but also because it makes it very easy to do live coding. The experience of wearing a Quest and you're in another world and you're looking down and you're making coding changes and the world changes for everybody in real time is incredibly powerful. once you've tried that, you never want to go back. Live coding in shared multi-person VR is the bomb. So here are two students who are doing a shared project, and they're seeing each other in a virtual version of our lab. We took our actual future reality lab, that's future reality lab behind me, virtually, because I'm not really there now, don't tell anyone. This whole sheltering at home thing. But we took our lab and we created a one-to-one representation of it that we could make available to the students as a model, and they could start building things in the virtual version of the lab, so they could physically walk around in places in the lab, etc. Some of the students, though, decided to do other things. Like these two students are dressed very differently in the lab because they decided that their project would take place on a beach, you know, and they're playing a game around a beach. So the goal for this is to get the mindset of the next generation of computer science, designers, game makers, artists, architects to be thinking, we can all put these things on and have shared social experience. And it can be in the same physical space, it can be in a different physical space. You shouldn't actually think of that as the fundamental dividing line. If I want to talk to a friend, maybe they're in person, maybe they're on the phone, I'm having a conversation with them. The co-located, non-co-located shouldn't be the high order bit. So in our lab, our future reality lab, we are thinking about this future of co-location, but we're also part of a much larger group that's mostly at NYU, but collaborates with other places like University of Arizona, where we say, what happens if you're not in the same place? How do we extend this? Now there are issues of latency, of spatial audio. There are all sorts of interesting questions that come up when you want to feel as though you're in the same physical space, but you want to use the sense of being in the same physical space as your gold standard, because you want to have proprioception, eye gaze, all of the subtle little things that say, I'm reading you emotionally. You want to get to an emulation of physical colocality, even if you're not physically collocated. And we see this in science fiction. We see this in the Jedi Council. We see this in the conference room scene in the Kingsman. This idea that we're not physically here, but we have all the power of being physically here. So let's skip forward 5 years in the future. Well, let's see what happened the last time we did that. This is what we had in 2014. Skip forward 5 years in the future from that, and somebody, a very, very wonderful commercial effort, ended up coming up with the Oculus Quest. And basically what we had, which required $50,000 worth of OptiTrack equipment, and what is now offered as a consumer product, have very similar characteristics, except that this only costs $400 and you can just buy it at your local something or other. So this idea that whatever is going to be hard today, we should skip forward in 5 years and say, hey, that's going to be consumer items. So this is what I think is roughly going to be, we're going to have one way or another in 5 years, whether it'll be Facebook or Apple or Amazon or Sony or Microsoft or one of the usual players. They're all going to be trying to make some version of this. And the key is to have as little as possible on the device itself. You need a 5G and eventually 6G transceiver. Of course, you need an inertial motion unit and tracking cameras and a microprocessor, but you really want the processing to be taking place somewhere else. And communicating. And in fact, if you look at the whole ecosystem, it's what I call 3-edge computing, where essentially you have your lightweight wearable, you have this something that you carry around with you that's talking ideally to some powerful PC that is doing the next level semantically up of, say, machine learning, understanding hand poses, facial expression, and that ultimately talks to the cloud, and the cloud is doing the really heavy lifting of data-intensive analysis and sending down in a compressed form the scenes that you're seeing around you. So there's a tremendous amount of work to be done in the connections between all these 4 components of 3-edge computing. But how do we get people to really hang out together? Well, I have a problem with the fact that avatars are all floating around without feet. So we've been working on trying to solve that in our lab. We've been trying to create, we've built these shoe insoles that when you look at them as a technology, what they're doing is creating an image of pressure. And if you have an image of pressure, you can start using that together with IMUs, together with other information and headset to start inferring full body poses. In fact, we're not just getting pressure, we're also getting shear forces. So if you look right up in the toe here, and I do a close-up, you can see that I'm not just getting pushing down, I'm also getting this and this, which means when a person is starting to lift their foot up, I can figure out what direction their foot is going. Then we combine this with machine learning. We put people in OptiTrack suits and we use that for training. And then that means that if I only have head and hands and feet, I can start inferring full body by using a machine learning algorithm. In fact, there's our training phase, and then we use that with high quality mocap, semi-supervised corpus of prior movements. And we can say, great, now in runtime, all we have head and hands and feet. And we can do things like, hey, all I have, in fact, this is something that's running live here on my laptop, which is really just a character where the only thing I have as far as data is head and hands and feet, and the rest is I'm just actually inferring everything else algorithmically. So this is a capture we did of one of our grad students, and we can infer the rest of their body. Which means that we can bring this to everyone as long as we put these things in arches, basically, essentially like having bowling shoes, except everyone, everybody has arch support now. Why not have everybody have this kind of support instead? So if we continue to 2025 and we assume we can do this, what'll theme parks be like? Can we have a self-sustainable economic model? Can we have experience service economy where you have somebody who is actually your virtual bartender or the virtual actor in the play, where customers can feel co-located, but they can interact with remote performers? Basically Ready Player One, but the real version of it. And in this service economy, when you need to talk to a person, they will just beam in. It'll be an asymmetric interface, just as the waiter doesn't have the same experience of the restaurant that you do. They're working, you're playing. And when they're too far away, you have AI bots. This could actually have a profound effect on the economy, because people who are in low population density areas can have gainful employment in the new experience economy. So that means you can go anywhere. Where do you want to go? Let's make participatory worlds. Anybody now could inexpensively, using only consumer equipment from wherever they are, in groups, not in groups, beaming in together. They could all go to the Shire. They could all go to Tatooine.
They can.
Oh, I know I have to wrap up, don't I?
Yeah.
They could all go to Hogwarts or to worlds we've never thought of before. So the future I really want is, I want objects to appear anywhere we want them. I want creatures to show up in front of me. And essentially, I would like children to grow up in a world which is essentially Harry Potter meets Harold and the Purple Crayon. And that is my rosy vision of the future. So thank you very much.